Hey everyone, and welcome back to the Information Bottleneck podcast. And today we have a special guest, Judah Goldfeder. He's a PhD candidate at Columbia University and also a student researcher at Google. Hey Judah,
Hi, great to be here. Thank you so much for having me.
thank you that you come here. Hey Alan.
Yeah, it's good to be here with you and Judah. For those who don't know, we've actually all three of us been co-authors on a few papers,
Yeah,
and
quite a
probably
bunch.
quite some more going forward. It's good to be with some friends.
Yeah, and I'll be seeing you in person, I think, at NeurIPS in a week, right?
Yes, that'll be very fun.
Yeah, I can come. I'm moving apartment, so enjoy without me. Okay, so today we are going to talk about a lot of very exciting things, robotics, and why we can reproduce experiments, why we can't reproduce experiments, and a lot of very interesting things. But let's start with some news, very recent news about TPUs and Google, and it looks that Google tries to sell their TPUs to other companies, and they estimate, at least this is their estimation, that they can get like more than 10% of the total market. And based on this news, Nvidia just the stock price of Nvidia just dropped 3% or something like that. What do you think about it? Do they have any?
Well, my perspective on this, and I'll give the caveat that this has nothing to do with my affiliation with Google, but I'm kind of surprised that they've taken so long to do this. I mean, TPUs have been around for over 10 years at this point, I believe, and their strategy has been very much like, we use TPUs internally. We don't really care about marketing them. So to me, it's mostly just baffling why they woke up and decided now it's time to take part in this massive market. That's kind of my main question.
Well, yeah, and I'll quickly note that this is specifically over rumors of a Meta signing a large deal with Google over TPUs. First of all, Meta is known to be very willing to explore alternative data center architectures far more than almost any other major so-called hyperscaler. But beyond that, TPUs, at least for public cloud today, are uncompetitive, right? $3 an hour for Trillium, the TPU V6. You can't even rent TPUs like Ironwood V7. So Google will need to make significant changes in order to get a large community, like any kind of open source equivalent user base to what CUDA and Nickel has. And I think that really does keep the amount of damage TPUs could do to NVIDIA really limited, right? I think that, yes, it's training Gemini, and yes, Gemini is very good right now. And yes, it does leave Google Cloud more room to have more GPU capacity that's dedicated to public cloud. But I was just at Supercomputing 25, and all I saw at the GCP booth was them talking about their new GPU stuff that they're adding. Not this crazy focus on TPUs. So I think that, yeah, it's very good that TPUs are now being sold in large quantities to other customers, like to a major customer, rather than being uncompetitive on public cloud. But I still need to see a lot more before I'm ready to sell my NVIDIA stock.
Well, I don't know if the current prices are really representative, because if you just think about it from Google's perspective, right, they've been using them internally for a while, which should demonstrate that, at least based on their cost estimates, it actually is at least as efficient, right? So it's hard to imagine that TPUs are really less cost effective. Maybe they're more expensive, but that's not necessarily the same thing as actually less
Well,
effective.
they're keeping all of their inference stack and training stack internal because that's privileged IP. So it is for them cheaper, right? I don't dispute that Google can run their TPUs cheaper. I dispute that anybody else can, except maybe Meta right
Uh,
now.
I'm not sure to understand your argument here. What does it mean that like they can run
Yeah, I
their
don't understand that either.
inference and their pipeline cheaper?
If you have you tried to use TPUs? Have you seen the support for it? For example, VLLM support for XLA, the backend that you have to use is terrible. VLLM doesn't even support V6, let alone oven. They only support V5e on TPUs. So you're forced to switch to Google's equivalent to VLLM. I forget the name of it, but it's a very limited, crappy project right at this moment. That's that particular inference engine that you, the public cloud consumer, is not how they're doing Gemini internally. It can't be. Even if that's my point. That's what I'm saying is Google can run it because they have better tech to run them than the public does.
That's a software problem, right? If
Yes, correct.
GPUs are available for cheap, that will solve itself, I think, pretty quickly.
Well, it didn't for AMD or Intel by having cheap GPUs, right? Like MI300X or 400X has still not really moved the needle, right, for AMD,
But I
despite
think like, yeah, but I think like at least for Intel, I think also for AMD, there wasn't a point that they have like really good GPUs that can actually compete with the latest GPUs of NVIDIA. And I think TPUs is quite unique in this sense that like they're really good, they're very, very efficient and fast. I don't know, Google has enough money to subsidize it even if it's a bit more expensive. A group of people to fix, I don't know, a lot of problems, compatibility with VLMs.
Yeah, there's also, just as an interesting side note, right? The history of GPUs is quite funny because NVIDIA, for most of its history, was a video game company. And then they're like, maybe we're a video game company, maybe we're an AI company. And kind of only recently have they really decided that they're an AI company. Whereas TPUs have been designed from the get-go for machine learning, workloads. So it's not surprising there may be some untapped potential there.
Yeah, but this is the argument for the last, I don't know, I hear this argument for at least 10 years already, right? It's like, yeah, GPU is like very general purpose. It didn't design for AI. So probably there were like hundreds of startups that this was their pitch, right? No, GPU is not good for AI. It didn't decide AI. We can make something better. And till now, it wasn't the case, right?
That's true. Although to some degree, AI has kind of evolved in the image of GPUs, right? Part of that is because all algorithms today are deliberately designed to run efficiently on GPUs. So maybe it's like kind of chasing each other.
Yeah, I would agree with that description of it. But I also I'm sorry, Ravid, MI450X from AMD is, if you squint and really look hard, it is up there with like Vera Rubin. And I claim that AMD is kind of doing what they need to do from the hardware level to give a real competitor, up to the point where Oracle's built an AMD 450 cluster. They've already said they're getting 50,000 450 Instinct GPUs for a limited kind of deployment. Now, I realize that there's always going to be a certain amount of people that will not trust monopolies in general and will buy AMD even if it is more expensive, even if it is worse. But I point out that switching from CUDA to AMD is easier probably for most people than switching from CUDA to TPUs. Also, we have problems. Can Google, I don't know maybe I should know since I claim to be an expert in semis. I don't know who's fabbing the TPUs. If it's not TSMC, if it's like Google, for example, now you've got questions about can they deliver, let's say the market swapped over and was suddenly obsessed with TPUs. Are they prepared to deliver though? I don't think they are. I think supply chain bottlenecks will keep GPUs in a dominant position even if people were ready to swap software.
Yeah, I don't know. And we will see. I think we'll see, but I think it's still very interesting that other companies even consider to move to TPUs, and maybe they will start to use JAX, right? Besides Google, no one actually uses it, right? I don't know what is your opinion about JAX, but
my opinion about JAX is, so Google had a problem that no one was using TensorFlow anymore but them. So they decided they needed a new library that only they would use. So they made JAX.
So actually, the story, so at least when I was at Google 2018. So the problem was that TensorFlow actually didn't scale on their TPUs. Like they started, I think it was like maybe the first or second generation of TPUs. And TensorFlow, like you can't, even inside Google, you can't parallelize runs over different TPUs. And then they developed JAX just to do that. Like this was the only goal of JAX, to understand how you can scale and parallelize over different machines with TPUs. And every time I must say that, like, again, in the last 8 years, I hear this again and again, like JAX, like, is so good now, like it's already like has the right abstraction, right? They build it the right abstraction, and I'm trying it, and it's not.
Yeah,
you can compare it to PyTorch.
No, I would say having used PyTorch and JAX and TensorFlow, PyTorch is way better than the rest.
Well, and then you're now at PyTorch's XLA backend, which is nowhere near as good as its CUDA backend. And so this is the problem: is you have to get that critical mass of users, especially ideally open source, who are going to do that work for PyTorch to make XLA compatible.
There were a
The
bunch of
CUDA,
people
sorry.
inside Google, I think, that wanted to use PyTorch for a while. There was a whole movement that didn't really go anywhere, but that kind of
What about Keras? What do you think about it? So I was a big fan of Keras again, 6,
yeah.
7 years ago.
Me too. Back then, yeah.
Yeah.
At this
And,
point,
but
yeah. I was gonna say at this point, I mean, I definitely first got into deep learning with Keras when I was in undergrad. I was like,
Yep.
you know, it's not like
Me
magic,
too.
right? Import Keras, you know, to train the model, it just works. I think at this
you're
point,
too
though,
young.
what do you say?
You're too young. I started like with a cafe and Tiran and all these
Yeah.
libraries.
Sure. But I think at this point, PyTorch has kind of caught up to the point where I don't really see much advantage, even of Keras. PyTorch implementations are just so simple and straightforward.
Yeah, I agree. You can. I think like now you can change the backend of Keras, right? You can change it from JAX to PyTorch or whatever you want, and it may be that in some cases, like you will see a significant boost in the performance, but maybe it doesn't worth it. Yeah.
Well, so there's also stuff around, like, what is it? Lazy versus eager. No, it's the CUDA graph thing. There's differences between.
Yeah.
And finally, the creator of Keras, his name's Franz Cholet, something like that.
He wrote
What's
some
he
pretty famous
been?
book, right? He wrote
Yeah, he's quite famous. Whatever
yeah.
happened to him? He kind of, I feel like he dipped out in importance ever since ChatGPT.
Yeah. I don't know, but I think like now these days you can also pre-compute the graph also in a Python, right? You can compile the model. This is exactly what you're doing. When
Yeah, and I
you're
don't
like
think these
making
things matter
models
so
that
much anyway,
compile.
because these are kind of more questions when you want to be serving the model. If you're like doing research, you're trying to just develop models quickly. I don't even know how much we care.
Yeah, that's true.
Okay, what about, so did you hear the White House? It launched the Genesis mission to empower, like to accelerate AI experiment. And if you don't know, so this is like, the idea is to get all the federal agencies, all the, I don't know, all the universities and labs, like the national labs together to create one machine, one system that all the data will be there, all the compute, all the best researchers, right? And to accelerate AI development in different domains and different topics. What do you think about it?
Well, I'll give some, I guess, historical information. I am kind of, my PhD in some way is the product of an earlier government initiative. When the government wanted to invest in AI, probably 5 or 6 years ago at this point, they started these like AI institutes. There's now like 30 of them. And my PhD is in one of them. It's called the Dynamic AI Institute. And so that kind of allowed me to do my PhD. So I'm definitely very grateful for government AI initiatives. But at the same time, I'm not sure how much this makes sense. It feels to me a bit like, we need to use some buzzwords, get the word AI in there, but the goals don't seem very clear to me.
Yeah, and I've been like scrolling through this executive order. So apparently, whatever costs there are, which are not enumerated directly, will be borne by the Department of Energy, which is already a not heavily funded federal agency. And the things that are described in here, basically, it comes down to like, let's open federal data sets up to be accessed and basically solicit people to come work on this. I am not seeing very much in here that is meaningful at all. And in fact, as much as I hate to say it, this is one place where I'm really glad that we're getting these wishy-washy and like deregulated efforts, because I do think that government has no idea what to do about AI and shouldn't even try, in a sense, until we've seen the kind of scenario, like some absolute catastrophe happen, which is probably, even with today's models, not really possible yet. And so it just looks much ado about nothing, I think, is the name of that play from Shakespeare.
Yeah, I mean, yeah, sorry, you were saying?
In some sense, I agree with you. I don't think like the government needs to directly fund it and try to integrate all the different aspects of AI research. But I also think that like the goal or like the role of the government needs to regulate it, right? And needs to understand like where and what are the bureaucracy that you actually need in order to make like an efficient research and an efficient um development in AI. And it's much more difficult than to say, oh, I don't know, I will generate, I will create a unified organization that will do everything.
Yeah. But this doesn't sound like that at all. This is kind of more like we're gonna just look at our own data and use it.
I agree.
Yeah, it's like information sharing and coordination. That's all it is. It's all about partnerships, clear policies, uniform. Like if you read this, that's all it is just like, please work together. That's what the
And the
executive order
government is
said.
famously very good at organization and sharing information, right? Those are the hallmarks.
Yeah, I think, but this is the problem. Like when you don't want to put money in, right? That like you can have it like you wrap it in nice words, and yeah, we are doing it together and sharing. But
I'm surprised they didn't put some more buzzers in like quantum or something, just to,
They did. They did. There's quantum all over this.
Is there really? No,
Yes.
no.
I've been reading it the whole time, and they did.
They
Quantum
did, okay.
information science and nuclear fission and fusion is in here too. Nuclear
Whole thing.
fusion and quantum.
multi-agent systems that will make it more efficient.
I haven't actually seen agents in here.
I want to start a company called Quantum AI Agents. We're not going to have any description of what we do. We're just going to get funded to do something. That's kind of been my goal for a while now.
God.
1 billion funding is next week.
Well, do you believe in like D-Wave? Because I've read enough about quantum information science to realize that quantum decoherence and error correction is really hard to possibly impossible. But quantum annealing seems marginally more possible, even if we don't get quantum supremacy. So is D-Wave? I've been telling people they seem a little bit less of a scam than the rest. But
what is D-Wave? I don't know anything about
familiar.
it.
They're a quantum startup that claims to be able. Do you know simulated annealing, like the optimization technique? They claim that they have a quantum analog to this that is faster to solve global optimization problems. And I have to go check to see if are they even doing anything anymore. They were the OG. Yeah, there you go. Everybody's talking about them right now. I just typed them in. Motley Fool. Is D-Wave Quantum a millionaire maker stock? So they're having a moment, apparently, right now.
My perspective on this stuff is I don't think quantum algorithms are going to be the problem, right? It's building the actual quantum computer. I think it's pretty clear that if we had a big quantum computer, quantum algorithms are going to be very useful. I'm just not sure what computer they plan to run this on right now.
Well, so quantum annealing doesn't require a universal quantum computer. Apparently, it's like a limited. And that's why D-Wave is so exciting, right? Because they don't claim quantum supremacy. They just claim that they're like actually faster at optimization. And so they could be like, if that worked in principle, the quantum agents thing that you talked about should work. You should be able to train an LLM with this quantum annealing for AI agents.
I have a friend who's doing his PhD in quantum computing. I think he would be rolling his eyes, but
yes.
I think, but it's interesting, to compare between AI and quantum computing, right? Because like, I don't know, 10, 15 years ago, they were like much or less in the same situation. Like it was like a big promise, but didn't actually work in practice. In the last 10 years, right? AI just take everything, and deep learning actually just make huge progress in so many fields, right? And now so many companies, so many startups, so much money into the field. And quantum computing, I know, I hear again in the last 10 years, I hear all the time now, like IBM just succeed to make, I don't know, 80 like quadrobit or something like that, and all these companies that are like startups that are doing. It sounds very incremental progress, and it's not clear like what we want to do and what are even the steps, at least to me. What are the steps that we need, or what are the breakthroughs that we actually need in order to make it work in real world problems? And so, but I'm not an expert. I really don't know almost anything about it.
I think without quantum computing, though, everybody would just forget that IBM exists. I don't know if
I was about to say, I would expect IBM. It'll come out of IBM, right? They're the ones that have been the long
that's what they're doing. But like
working.
they used to be such a leader in AI, also, right? They had Watson
And
2020.
Project Debater, which I
Yeah.
just tried to follow up on.
Yeah,
Yeah.
they had Deep Blue. They
Blue.
were really a leader in AI, and then they decided, you know what, we're going to bet on quantum instead. The one company that was like, you know what, let's defund the AI stuff. Right? It's not working, and they did this in like 2010, which is just such poor timing.
Yeah.
But I think also like Google has a very strong quantum computing
Yes,
team.
yes,
No? I think
they
like
do.
they have like once a while there is this article about now they succeed to make very unique quantum computing machine that make it a bit better than before.
Yeah,
Okay. Anyway, maybe let's start to talk about robotics.
yeah,
If you don't know, Judah is an expert in robotics and is PhD in robotic labs.
yes.
So tell us.
Yeah, it's a great experience. I think one of the coolest things to do. It helps a lot, I would say, with children. Whenever my nieces or nephews ask me what I do, I always say I build robots. Much easier to explain than deep learning, let me tell you. So definitely a big plus to that. But yeah, I've gotten to work on a lot of really, really cool projects. So I work at the Creative Machines Lab at Columbia under Professor Hoda Lipson, and we're kind of known for building the really out there strange robots. In particular, we're one of the first groups that actually thought about what it means for a machine to be conscious, which is like a very, very controversial topic. But like consciousness, self-awareness are kind of the things that we work on. On these topics, I find most people either struggle to define what these terms mean. Like if I ask you, what does it mean to be conscious or self-aware? People will either give you answers that are circular or hand wavy or imprecise, or they're going to give you an answer that's so basic that's kind of obvious a robot could do it. So we tend to take the second group of answers and kind of like run with it. So yeah,
But
build
is
all
it
sorts.
like,
Yeah.
does it mean, but why we actually need a good definition for consciousnness or like whatever,
Well,
self-aware? We can just build things, right? Like we have very good LLMs without it, right?
it's a good question. So this goes kind of to a really heart of the definition of AI. If you look at the book, I think it's called Artificial Intelligence: A Modern Approach by Russell, like one of the classic AI textbooks, like the first page, they have this debate. That is artificial intelligence, is it thinking or is it acting? It's kind of the big philosophical question. So I think today we've mostly focused on acting intelligent, right? LLMs really care about acting, but actually thinking, the cognitive process might be more important. And it could be that the reason why we're seeing a lot of hallucination or issues with large language models is because we've focused so much on acting intelligent, we've kind of lost thinking intelligently. So it could be that these notions, they might be a bit grandiose, but it could be that actually understanding important parts of the human cognitive process are actually the key to unlocking real intelligence.
I will quickly just wait in and say, so the Ravid's asking, why do we care? Well, philosophers are going to very hard care, even if, we AI people can ignore caring about it. But I also think I interpret some of this stuff as cogitoist propaganda, as I like to call this, right? Which is the idea, the cogito is Descartes' famous think, therefore I am type argument that the appearance of thought is an ontological proof of existence. And I think that this is also very relevant in the context of saying, oh, I'm a conscious, I'm not a P zombie, right? Which is the theoretical thing that operates like a human, but is not a human in that it doesn't think, right? And
Mhm.
I tend to take the belief that the appearance of thought is not necessarily thought, and that the evil demon is actually the world we live in. Radical skepticism is the only correct answer. So I guess my point is, in that world, I would say that the appearance of consciousness is consciousness. Like I'm willing to just accept that and say that what we even think of as thinking going on in our mind, it's like a qualia, right? That we have to ultimately has that subjective, I don't know, right? Like there's so many people arguing deeply about this, even outside of AI. Some of my favorites being Daniel Dennett, right, who died recently, unfortunately, but he wrote a lot about some of these kind of questions about like what is consciousness and reasoning about it, even from a computationalist standpoint.
Yeah, it's definitely an age-old question that really humanity has not made much progress on this philosophically in like 3,000 years. So I'm not so sure we're going to solve it.
Well,
But
and Blade Runner is a movie about this concept, right?
yeah, that's the That's the movie that's from what's that novella? Do Androids Dream of Electric Sheep? Was it?
Yes,
Yeah,
from what's his name, Philip K. Dick, who,
yeah.
by the way, not enough AI researchers read good science fiction.
Right, do you have any
It is
idea what we're talking about? I'm
crazy.
curious.
I don't know. I must say that, like, maybe, yeah, like this is very philosophical, like, debate, or very philosophical argument. But like, I don't know. Like at the end, most of the progress in AI was without any connection to these debates, right? Like again, we can hand wave about, I don't know, components that are like using humans or things like that, and you have
Wait,
some similarity.
wait, what about Elijah? There was all those discussions right when Elijah came out, right?
I'm not familiar with
So
Isn't that the name
Elijah.
of that early chatbot? Hold on, early chatbot. Oh, yeah, it's Elijah, Eliza, from the 1964 to 66, where he wrote like a really simplified, like kind of if else set
Yeah, yeah,
of
yeah, yeah.
like
I'm
thing.
familiar with that.
Yeah, and then
I
and then
pronounced that differently in my head.
he had like a secretary or whatever that started, or a few people who used it started like really getting basically the early version of LLM psychosis from it.
Yeah, I agree with you. I'm gonna actually push back on that a bit, Raveen. I think if you take like a long history of AI going back to like the symbolic era, for like the first, I don't know, the 40s, the 50s, the 60s, the 70s, the 80s, all the stuff going on, none of it worked that well, but it was all very focused on the thinking process, right? The shift to focus purely on the outcome is mostly from the deep learning era.
For the record, Eliza effect is a Wikipedia article referring to people's tendency to project human traits onto rudimentary computer programs which have a text interface.
okay, so let's assume that like it's very important and very interesting how you tell us how you actually build a real robot.
How you build a what? Say that again.
A real robot.
Yes, a real robot. Well, so yeah, there's a lot of challenges in robotics, I would say. I think if you were to ask people 10 years ago, or certainly 20 years ago, what's harder, having a robot walk around Manhattan, or I don't know, I'm not sure how you would describe ChatGPT to them, or an all-knowing chatbot that just can do your homework for you and write code and whatever. I think everybody would have said the robot's easier.
Not Moravik.
Not more.
I guess that's true. Most people, I should say. Fair enough. Fair enough.
Okay, and if now we will ask you, what do you
Yeah.
think?
Well, obviously the answer is it's harder. And the question is why. I think it's also worth pointing out before we delve into the why that to some degree it shouldn't be that surprising if you think about it from the following perspective. If you were to ask most people why do they not have a robot butler? I've actually done this. I've asked many people, like lay people, not AI people, what's the reason do you think that you don't have a robot butler, right? A lot of people think it's because we can't physically build them, which is completely wrong. We've been able to have robots that are physically agile enough to walk around your house and go up your stairs since like the 90s, maybe even earlier. It's been entirely a control problem forever. And the reason why it's so hard, well, it's a lot of things. First of all, the real world is just so unpredictable. And it's not just unpredictable, it's also unforgiving, right? If you make a hallucination in, a language model, nothing happened. But if you hallucinate that there's no person there and you just punch them in the face, it's quite a big problem. Like one of the things we've explored on this in particular is there's like a very basic thing in robotics, right? You know intuitively that if you take your hand, right, and you try to punch yourself in the stomach, you really can't do it because your brain knows that that is an illegal configuration of your body. It doesn't work.
Now all of our audience is trying to do it,
Yeah,
right?
don't try this at home. Don't try this at home. But your brain knows it's called your mental configuration space, right? Your brain knows this is not a thing that I can do, but robots don't intuitively know that, right? Just give a simple example. And so hallucinating, something about your body morphology could also lead to like damage of the robot, right? A robot that's not properly trained can just break or destroy itself. And also the real world is constantly changing. So, something basic like I moved my dining room table, my room is different now. So there's so many details of planning and things changing and risk. And then I would also add that the data modality is so different, right? Robots primarily need to deal with, it depends what your sensor is. It could be video, it could be, I don't know, LiDAR, whatever it is, but it's a completely different modality than text. And the main difference, I would say, is that text is very, very semantically rich. You don't need to do crazy feature extractions to get something very meaningful out of text. Whereas videos have so much redundant information. Ravid, you seem very true.
Yeah,
I
I'm
will
just
say, tokenization absolutely is crazy to me, but yeah, it's everything else you said.
no, but okay, I will push back on I think all of your three points actually.
Please.
And correct me if I'm wrong, okay? Because like again, I didn't work on robots, so tell me why I'm wrong, okay? Maybe. So first, like hallucinations. So it means today that like right, like even though like you have some hallucinations, once in a while in the current LLMs, like it's not a very severe problems like for most of the cases, right? So like most of the time you don't have hallucinations. So I'm not sure. Do you think like robots are like, have like the same amount of hallucinations and then most of the time they're okay? This is okay,
Yeah,
maybe
let's start with that. I
answer
think
this one.
maybe it was a mistake to use the word hallucinations because hallucination is really defining a phenomenon that only really exists on LLM. So I don't know if hallucination is quite really the right word to use. Let's just say mistakes. Right? I think it's more the correct term. So I mean, with robots, it really comes down, I guess, to precise to like sim to real transfer because most of the time you're not really training the robot in the real world. And there's kind of that really boils down to the issue, right? And so it's not that hard to have a robot that traverses a simulation very well. But the transfer to the real world can lead to like many of these mistakes. And yeah, maybe the mistakes are rare, but the truth is the more different your environment is from your simulator, the less rare it becomes. So I would say that when you're talking about robotics and it's like a very static environment, like a flat floor, a clean room, it really is a solved problem today. It's not hard for a robot to navigate around an environment that's very similar to what it's been trained on, but it's really the issue of generalization to distributional shift in different environments that's so challenging.
And that's what gets to the push towards world models right now, which I'm sure we'll talk about more.
Yeah.
But before we talk about that, I referred to Moravec's name earlier in saying Peter Moravec or whatever his name is, but he's this scientist whose name coined the phrase Moravec's paradox, which is the idea that problems that humans have evolved for millions of years to solve, such as walking and continuous control problems, are far easier to solve in general than problems that humans have not evolved at all for, like chess, for example. And so I think that that's always been a fascinating one, is the role of evolution in, these discussions.
Yeah, for sure. I would say I definitely agree that, we need to look more towards nature. Like evolution is the only example of an algorithm that produced a real intelligence, right? So I think there's a lot of truth in that. Yeah. Ravid,
You're muted, sorry.
Sorry, yeah. So this was my first point, but like the second point is also that like about the data, but the richnesses of the data. So
yeah.
I don't know, like even if like the like text has like more data, but like also we know that in vision, for example, right, for static images, or like even for videos, AI works really good
Yeah.
these days, right? You can create good images, you can understand videos. Again, it's not perfect, and you can claim that this is like the difference between like real world product actually works and what we have today, but it works quite okay with in different modalities. So why robots are so special in this sense?
Well, I will say a few things. First of all, I think there's been a lot of progress on that quite recently. So, a lot of the things that you're saying work well. I don't know if I would have even agreed a year ago on some of those issues. So it could be that we will see within the next few months some steps moving forward. But I would say even the things that work well, I think they might be more choreographed than we'd like to admit. I'll give you a few anecdotes about why I believe this. First of all, let's talk about Boston Dynamics, right? You look at Boston Dynamics, they've had robots doing backflips and dancing and all sorts of crazy things, right? So you have to ask yourself, if all that's real, I don't believe they're lying. I think they're honest. But if all that's real, then how come there isn't a robot doing a backflip that I can buy, right? Or that I can even see? That's one example. I'll give you another example. There's a very viral video over maybe a year and a half ago at this point, roughly, where I think it was the Tesla robot, but maybe I'm forgetting, doing dishes. Do you guys see this video? And it looked so autonomous. It was like someone was telling it to do the dishes. It did everything, right? And again, I have to ask, if this was really true, why are we not seeing this? Why do I still do my own dishes, damn it? I don't want to do my dishes. And I think the answer is these videos are still choreographed. And that goes back to what you were saying. These models do work very well, although this gets back to another topic you mentioned, you were thinking about, which is kind of reproducibility. Do these models really work as well as they claim to when the people testing it aren't the ones writing the paper? And then I'm kind of a little bit less sure. So yes, they work well when we cherry pick, or they work well when we stay close to the distribution they were trained on, but suddenly this robot's in a different kitchen, it's a different model dishwasher, and it's completely useless.
And how much you think like the reason is that you have very different, let's say, worlds. Like you have the algorithmic world that like you need to develop algorithms, and you had the physical world that the robot needs to actually to play or like to move in this world, and somehow you need to connect them, right? Like you need to co-develop them. And how much you think like this connection is actually like difficult to make a good robots?
Yeah, it's definitely very important. I think we're seeing more and more that robotics is becoming a subfield of AI for this reason. It used to kind of be that robotics was, it's always related to computer science, mechanical engineering, but it was kind of more of its own thing. But now we're kind of seeing that the people building the robots to do anything useful need to have a strong understanding of the machine learning stuff. Very, very strong. Because if they don't, it's really just hopeless. So I think these two things really need to go hand in hand. And I think most roboticists understand this very well. I think maybe in the AI community, people realize it less.
And do you think like we will see combined algorithms that will combine some ideas from LLMs and will just like change them a bit, adjust them a bit to robots, or think that we'll see, I don't know, world models that don't use text at all, or something in the middle?
So to me, I think we first had to ask a question that maybe you could answer or we can discuss, which is how exactly do you define a world model? Because I tend to think any model that's answering this question must definitionally be a world model. You know what I mean? So like maybe you modified an LLM, maybe you're using a JEPA, but if you're using it to have a robot navigate, how on earth is it not a world model? Maybe that's
Yeah,
kind of like a branding question, but I don't know.
I was just going to say that today's world models are basically just video models where you can move around the video, and that there might be an agent that can control the moving around the video. And that's what we call world models today. I'm aware that the vision is a holodeck-like experience, but they're not quite there yet.
I attended a talk at ICCV on world models, and the lecturer said something funny. They were like, the word world models was coined by Schmidhuber in some paper, and that was his only contribution.
That's
Which I thought
well.
was
So Schmidt. I thought that Yan did it in the original Jeffa paper. Oh my God,
well.
Schmidhuber.
Oh man, this is this is a can of worms. Maybe we don't need to get into. But the point I was trying to make is to some degree, I think the term world models is confusing because when people say world models, they really mean what Alan said, right? They mean like these models that are learning video dynamics. But any sort of model, like Ravid, you were saying, that solves this problem, I think you must call a world model. But to kind of answer your question, whether it's going to be what we are now calling world models or something else, it's very hard to say. My intuition would tell me that LLMs wouldn't solve this problem, but I have to have a little bit of humility, right? Because I did not think LLMs would solve half the problems they're solving today. So I don't know.
Yeah, I know. Like we talked several times about Japan in this podcast, right?
Yeah.
The idea that you can learn something in the representation space, and you don't need to couple the generation process with the learning, right? And by the way, this is like a good time to like Jan will come like in 2 weeks.
Yeah.
So and probably we can talk about it. But I think like the at least as I see it, when I talk about world models, I think it's something exactly this. It's like you don't need, you have some internal structure, right? That can help you not to do all the actions in the output space, right? That you can take and you can quite think, but like to represent something that is not only the generation process. Okay, you have some
Yeah.
internal world
A
model.
latent thought process. Yeah, I definitely think that's very, very important. But I'm kind of speaking from logic and intuition.
Yeah.
But I can't tell you that LLMs won't surprise us again. But yeah, I
So
do think. Yeah, sorry. Yeah.
no, but like, what people actually use these days in robots?
Yeah, people are not using LLMs, that I can tell you. I've seen many examples of people trying to use LLMs to control physical systems, and they don't work. They just don't work.
Well, hold on. What about virtual systems, like desktop agents and systems like that?
That does work, but I don't think that's the same thing.
Okay,
So
that's
if you're
true.
talking about like mobile agents or desktop agents where it's like navigating the web,
Yeah.
right? That's what you're referring to. That does
Yeah.
absolutely work. But that's because multimodal LMs are really good at understanding like, images and whatever. Like that is their strong suit. But I don't think they're definitely not being used for robotics. Like I can tell you, when we build robots, we're essentially training our own world models. That's the work that we do. When we want a robot to navigate, we have to build some sort of world model. It might not be a jet, but it might be, I don't know, an RL based world model, like control and whatever it is. But we're training our own world models. We're not using any sort of LLM foundation model. It doesn't really exist.
Why?
Because they're just not good enough at the physics. They're not going to be able to. There's no clear way to go from LLM to motor commands.
Yeah, but like this is quite surprising that like everyone are trying to retrain or like to train from scratch their own robots, right? Like then the physical world is the same, right? So we can say, yeah, this is very different if you are inside the room or outside the room. But like I would expect that after some a constant number of different environments, like you can use data from other sources.
It's true. I guess it depends what you're trying to do. So if you want to build a foundation model for robotics, there's kind of two things, right? There's building a foundation model for robotics, right? Kind of like, the LLM of robotics. And there's also just like solving the local task that you want your robot to do, right? So I was kind of more referring to the latter. You have a robot, you're trying to get it to do X, in like a local environment, it's a fixed environment, a single task. That's kind of when you still want to just train it to do that on its own. But you're talking about something more ambitious, which is we want a model that just does robotics, right?
But no, not even that. I think I don't know. I would expect it now if I want to develop even like a specific model, right? It's like that is doing something, walking in the room or like playing football or whatever. I would expect that it will get some benefit from using data that collected in other scenarios. That like I don't how to move the legs or whatever.
For sure, yeah. No, that is true. There definitely is a transfer learning that you can do, absolutely. But we still don't see kind of the foundation model level of LLMs in robotics. One of the students in my lab, his name is Max Segan. He's kind of working on building robotics foundation models in open source, which is a really, really interesting problem. But it's just so challenging. I'll also add that getting clean data is also difficult. Right. So for text, we kind of have some gifts like Wikipedia. For robotics, the clean, annotated, good data sets that are in the open source are more limited than you would probably think.
So do you think like what is the big bottleneck? You think it's the data, the algorithms, the compute?
I think probably a lot of it is data. I've had a discussion with some people once where like, why don't we just buy like a bunch of GoPros and just pay people to walk around and just record their egocentric data and just use that. Something like that would be pretty cool. But I do think a lot of it is data. Yeah. I think in general, I feel like maybe you'll disagree, but I feel like in general, we've learned that with transformers, data is the issue, not modeling. Like when have we had an issue? When have we had a problem with unlimited data that a transformer couldn't do decently?
That's the bitter lesson, right?
Yeah. It's also, people are saying that LLMs are kind of plateauing because they've already read the entire internet, right?
Yeah. Well, and now the internet's all just, taken over by LLMs.
Right. It's kind of a circular, right? It's a circular problem. Yeah. They're reading themselves.
Yeah.
So, but now maybe it's a good time to talk about synthetic data, right? So in LLM, you have synthetic data that the LLM generates, but you have also in robotics, you have like virtual environment, right? You have so many environments. Some of them are quite sophisticated, right? I'm not sure if it's enough, but they are quite sophisticated. You can learn a lot. And do you
I would
think
agree.
do you think it's a good direction?
Yeah, I want to kind of differentiate between two different types of synthetic data, at least when it comes to robotics. So you've got kind of simulator-based data, right, where you have like a real physical simulation, using physics, computing things, and then you also have kind of learned models, right, of the world. And so there's kind of a really big trade-off of how do you balance these two, because when you have something that's grounded in physics, you don't have the issue that you have with synthetic data, where when you kind of train synthetic data, there's a lot of evidence of like collapse. Do you know what I'm talking about? You see this with LLMs. There's a paper in Nature a while back that if you train an LLM on LLM data, and you do this a few times, eventually Perplexity just collapses.
Yeah, I think it was like Yarin Golf paper, right? He has a paper that showed, at least theoretically, if you have only synthetic data, at the end you will collapse.
Right. But that's not true if your data is like simulation based, right? Because then it's actually grounded in some physical understanding. So that's kind of one big advantage of these approaches. But at the same time, even the best simulations today are not the real world. So like actual real world data, or even just like a learned model that's actually trained on the real world, in many ways is going to be better. So I think the step forward is physically informed machine learning, which I'm sure is a topic you come across. But basically, it's kind of like building machine learning architectures that bake physics into them. So it's not just we're mimicking the world. We actually learn something about the underlying physics. So we have both the advantage of the learned model that we're really matching the distribution closely, but also the advantage that we're obeying the laws of physics. I think that's kind of a very, very powerful step forward.
Can you give me an example? Like, what do we want to have some machine that learns some? How you actually can learn this
So there's a lot of examples
internal?
of this. The most famous example are PINs, physically informed neural networks. The problem is most of the stuff out there doesn't really work yet. So I can give you examples of these things. You can look them up, but they don't really work so well. So they're all different. There are so many ways of doing this. You can, some of them try to bake the knowledge directly into the architecture. Some of them try to like introduce constraints into the training. But at the end of the day, I would say it's quite early stages. In fact, one of the papers that I'm going to be presenting on at NeurIPS, we basically, we were kind of in the field of scientific machine learning, particularly of trying to learn physical equations, like learning like complex differential equations, PDEs, ODEs, right? And this is kind of the field that a lot of these physical models were developed for. It's like you have some data that is developed, is created by some physical process. Can you kind of learn the underlying function? And our paper was a benchmark paper where we kind of took like the top 15 approaches and showed that they all kind of suck. That was kind of the result of this paper. So
And why I think is that because like you think it's again data problem? If you will have more
no,
data,
I think
you
this comes
can
down to a modeling
learn it.
problem that it's very hard, it's very hard to correctly synthesize these two things. They don't really go together, right? Learning wants to be free. It wants to explore every possible hypothesis, right? And
I'm not sure to understand. I'm not sure to understand. So like you have two issues here, right?
yeah.
One is the let's say how you construct the problem, right? Like how you define it. And let's assume that now I know that there is like I know the form of this physical law. Okay. I just need to find the right hyperparameters in some sense, right? And now I have the data, and you basically need to feed the data to these hyperparameters. So why I think that the current models don't understand how to do it?
So there are some types of data that a neural network will really struggle to learn. So like the simplest example of this is like a chaotic system. Are you familiar with what I mean by that? Like
I
I'll
know
give,
what
I'll give
is a
you,
chaotic system.
yeah. Like my favorite example of a chaotic system is like the 3-body problem, especially because there's a great Netflix show for those who know. But right, this kind of a system where like, it's very sensitive to the initial conditions. And if you just try to do like a regression based approach, it will completely diverge. Right. So this is a great example where like traditional machine learning cannot do this. And so the only way to approach these types of problems is you need to bake in some sort of physical knowledge, like some sort of differential equation solver into the machine learning process is one example. But the problem is even then it doesn't work.
Also, real quick, do convolutional neural networks count
As
as
what?
physics informed or something, with the idea being, oh, it's, more amicable for how images work, right? Of chunking them.
Maybe in a very loose way. I would say, convolutional networks are obviously, well, first of all, they're biologically inspired, right? They were famously taken
Yeah,
from a study about the eyes of cats. Yeah, but
really.
I believe so, yeah. But they're also, right, they have the
Yeah.
translation invariance, which I guess translation invariance is a physical property. So I guess you could say that in a certain sense, yeah. Yeah, definitely introducing like invariances that are respected is an example for sure. I never quite thought of them that way, but I hear your perspective. But yeah, that's kind of a good way of explaining the basic concept. We need models that have the right inductive biases for physical problems. It's kind of really the the thing in a nutshell.
But it's kind of like, I don't know, you go away, right, from data is the king, right, paradigm. That you just need data, just get more and more data and it will be fine. Why you think like we need it? Just collect more data.
It could be. It could be that that's the answer. And this is kind of contradicting what I said a few minutes ago. So I do admit that. But I guess to kind of be more precise, there are some problems. How do I say this? There are some problems that are fundamentally smoother. maybe that's not like a technical term, but there are some problems that a similar input has a similar output, right? Which you have to agree, things like language, even robotics are going to be mostly the same, right? Like even as complex as they are, a small perturbation generally in the input does not lead to a massive perturbation in the output, right?
In text is not so true. Like you can add just no, right?
Yes, but I don't know if no is a small perturbation. I guess it depends how you define these things.
Yeah.
Fair enough, but I guess in a lot of these chaotic systems, the smallest perturbation, and this is like a continuous perturbation even, right? The smallest thing will just completely change the system. So it could be
Yeah,
we need
yeah,
more data.
and it occurs to me that, the modality, like a single pixel, there's no equivalent to changing one pixel in text. Even the punctuation is far more.
Exactly.
I mean, in
Yeah,
literal pixels, it's just more, right? In terms of if you just OCR it or you know.
yeah, yeah. I mean, it's funny because we have famous examples in like adversarial machine learning, right? Where you change like one pixel of an image, and suddenly the AI has no idea what
Yeah,
it's looking at.
yeah, yeah.
And okay, so I have a question related to synthetic data. So do you think we will get to good enough simulations that will not need real data? This is like, okay, I would say it differently. So there is all the debate like what is harder, right? Generation or basically like discrimination and
Yeah.
like what we can, is it a good path to go like with generate good simulators or processes that give us data? And this is true for all the domain, right?
Mm-hmm.
Text, vision, video, whatever. Do you think in robotics it's a good approach? Like, do you think like we will get good enough simulators that actually can make our robots better?
Probably. I think the answer is probably yes. But I'll give a few caveats. First of all, I don't know if we really need to get to a point where we only use simulated data, but I think we can get to a point where we can do 99% of the training on simulated data and then just a small amount of fine tuning in the real world. I think that's kind of where things are moving towards. The main issue with this approach, though, is simulators they can be, very difficult to configure accurately to your scenario, right? I think that this is surprising to people who haven't worked extensively with simulators, but it's not so straightforward to just put your robot into a simulator. You
Why?
have to. So there's a lot of challenges. First of all, you need to accurately model your robot, right? You need to have an exact schema of, the robot's body morphology, its joints, what things weigh, all that stuff, right? And then you need to have an accurate model of your environment. And these things are very, very tedious. But I think kind of the right answer, and we're seeing this happen in the last few years, are systems that automate this process. So once we get to a point where I can just like scan my robot or take a picture of my robot, and boom, I can instantly create a simulator, right? We're getting close to this. Once we get to that point, I think then simulations will kind of really, really take over. Once these generative AI systems really get rid of all the barriers of setting it up.
But you still need to, even if you can either simulate, like if you can either model the whole robot or something like that, you still need to simulate the environment correctly.
Yes, but there's two challenges in that, right? One of them is properly describing the environment, and one of them is properly simulating the physics, right? Those are the two challenges. I guess what I'm saying is the second challenge to me is not such a big challenge. It's much because we know physics. The only issue with simulating physics is a matter of computational cost, right? That's the issue. And at least my long-term belief is when it comes to computational cost because of Moore's law, whether it's slowing down or not, in the long term, that's never going to be the bottleneck. But what is currently the bottleneck much more is configuring things properly. Like, how do I know the thickness of that material or what that thing weighs or how big that door is or all these things, right? It's so tedious to get that right. So if you could have all those details right, it's probably not that terrible to simulate the physics. I mean, sure, it's expensive. I don't mean to poo-poo it entirely. From like a long-term vision, that's not going to be the issue.
And do you think like we will have something, how to say, like in simple environment right now, like if you have simple environment, how scalable or like how transferable is the algorithms that we develop in simple environments to real world, like physical world, or like even just more complicated environments? Do you think the current algorithms are actually work and actually you can transfer them?
First thing, from a simple environment to a more complex environment.
Yeah.
No, I don't think so. I think if they worked, then we'd see them. I don't think so. It's kind of,
Why?
Well, yeah, the why is because they're just too simple, right? Simple to complex is never a good transfer. We need to have, I think you mentioned this earlier, but we need to have robots that were trained on thousands of environments, right? Once we can do that and they've really just seen everything, that will be a game changer, but we still just don't have that really.
But do you think like we can train them on thousands of simple environments, and it will generate the more complicated one?
Possibly, I'm not sure exactly what you mean by simple. So if you could elaborate on that, by simple, do you mean
I
like,
don't know, like the maze that some very simple right agent can go and find the right
yeah,
position and all these things. The
mm,
spider that tries to walk, all these
yeah,
simple
I mean, I
environments.
understand what you're saying. Yeah, the answer is, it probably will work somewhat decently, but the, there can't be too much of a distributional shift. So maybe it's okay. It's somewhat okay if they're more complex. But like visually speaking, that has to be distributionally similar, right? If suddenly everything looks different, it's not going to work.
And do you think we will need a better physical robot, or do you think this is something that we solve already and we just now wait for the algorithm?
So I'm going to say that I work in a robotics lab. I'm probably the only person that doesn't build the robots. So maybe they're going to be angry at me for saying this, but I think it's a solved problem. I think you just need to find a really good, someone, you have to be talented to do it. Definitely. It's not easy. But if you look at robotics papers today, it's the challenge is always getting it to do something. It's never building the robot.
No,
And
but
that's, yeah.
wait. It's not okay. I will try to rephrase the question. I'm sure you can build a robot, right? Like the actual robot that moves here or there. But my question is like we'll need a special or like new developments or new breakthroughs also in how we develop it when we run a specific algorithm, right? Because let's assume that now we want to run very specific algorithm unique that you think can work better, but it may be, right, in principle, it may be that it needs very unique or novel design or materials or whatever, right?
You're saying that like a different algorithm might need a different robot essentially.
Yeah.
That definitely is true. There's a lot of research on that. I've actually been involved with some work on that. So are you familiar at all with modular robotics?
But
So
like the truss links stuff.
yeah. So I think yeah, right. So Alan, we've discussed this. So this is one of the robots.
Yeah.
This project was led by a friend of mine and a colleague, Philip Wider, who did his PhD with me at Columbia, and I was working on them too. We basically built, and this is kind of like in my lab. We've done this for years, like a bunch of small robots that can combine to big robots, and this went very viral on social media. I think we got something like 40 million views across a bunch of platforms because it really reminded people of a Pixar movie, Big Hero 6, in which the villain in that movie, or I think actually the hero and then stolen by the villain, they developed like a series of these microbots, like little robots that combine to build giant things, right? And that's obviously a very different robot than what most people are talking about. But the algorithms that you can do with that, the things you can build are enormous. And so we actually built that out at Columbia. It was really, really cool. And yeah, those types of robots have way more applications. Like if you want, they can reconfigure themselves, right? So you want a robot to do different tasks, it can literally reconfigure its own body. It's a whole nother ballgame. Yeah.
I have a question. It's not really related, but like people they are trying to do kind of like our LHF version on robots with getting human feedback.
Yeah. You're
How
asking
you
if
do
people are
it?
doing.
If people are trying to do it, if you know some work that are trying to do it.
I think so. I mean, I think the name of that field, if I'm understanding you correctly, is human robot interaction, HRI. So yeah, people are definitely doing that. There's actually a conference that I think, Alan, we have a paper under review at HRI.
Really? Okay.
Yeah, see,
Nice.
a good reminder. Anyway, so yeah, it's definitely an active area. But I don't know. I haven't really seen RL being used so much. Maybe I just don't know about it. I'm seeing much more. It's much more related to designing the right interface. Is what I've seen. Right, kind of like human computer interaction. HCI is very related. Like you want to find how do humans connect, right? Like when Apple developed the iPhone, this is like a huge question, right? They had to figure out how do we connect with this little block of computer, right? So I
Mhm.
think when it comes to robots, it's much more of like a design question. I haven't seen RL really being used, but maybe I just don't know about it.
And what about different modalities, right? Like we want vision, we want audio, we want sounds. How difficult is it? Or like, do you think that it's important to combine different modalities in a robot?
I have one of my colleagues, my friend of mine, just wrote a paper about robots smelling.
All right.
So
That's the
What are the
next
results?
frontier. Olfactory. That's the
yeah,
next frontier.
olfactory.
Thank
Yeah,
you,
yeah, yeah.
Judah.
Shout out to
Yeah.
Obi-Wan.
Yes. Oh.
I don't know if robots need to smell. I mean, that's a little bit past what we need, although it is
One
cool.
of the senses, yes, they do. You need to
Okay,
give them
I'll
all
end
the
on
human
that
senses.
bandwagon.
Yeah, I will fight on this. Like, maybe not practical robots or whatever, but you want a real, like, human simulation. You got to give them all the senses.
Perhaps. I don't know if I would go that far, but I do think there are definitely modalities we do need. Yeah, like vision. I think audio is pretty important. Definitely sensory, like touch is an important modality. I'm less sure about smell, but yeah, I think that we do need many modalities to really kind of get to intelligence. And I think the proof is, going back to our conversation, is evolution, right? It's like, look at nature. Every single organism basically that has any modicum of intelligence developed all these senses, right?
Yeah, but you see, but it's a different question if you can achieve, reasonable or good enough robots without touch, for example.
Yeah, I mean, you really can't. It depends how you want to define touch, right? Do you want to define touch? What exactly do you mean? Obviously, you need some sensory information about when you're in contact with things or where you are, right? I think if you define touch as just like some sensor, on your limbs, and of course, you absolutely need touch. You know what I mean? Maybe we don't
Yeah.
need touch to the granularity of human. Do I need a sensor here and here and here and here? That I don't know, but we definitely need to know, am I touching something for sure?
Yeah. Maybe
Yep.
like,
Even humans, by the way, if you actually have very different granularity of touch in different parts of your body. Your hands are
mhm,
much more sensitive to touch than, let's say, like the middle of your back.
yeah, but like we also can have different sensor than humans, right? I know temperature, for example, instead of like feeling the heat, right? Things like that. That maybe that we don't need to mimic human.
I agree. In that part, I agree. I think there could definitely be alternative modalities, but I am skeptical that just video or just language will kind of get us there. Maybe we don't need the exact same subset of modalities that humans have, and that I will agree. But I think we'd need a few of them.
Yeah. Anyway, robots it's very interesting. I think like we will see. My personal belief that we will see it in the next 2 years. Let's say we'll see like a real robots that actually works. And what do you think? When we will see the AGI for robots?
I don't know. I think 2 years might be a little bit too short. I would say maybe like 4 or 5 years would be my guess. But really, who knows? I mean, really, I'll add. So I've been working on another kind of physical systems problem, which is on applying AI to buildings, which kind of might sound very different, but we kind of view buildings like as just a large robot in a certain sense. And we've been trying to, use machine learning to optimize the HVAC systems of buildings. And this is another problem that sounds so simple, and people have been saying we've done it, we can do it, for like 25 years, and still no one's done it. So I'm always very skeptical about these problems when they're always a year away. It's like maybe yes, maybe no. I don't know.
Yeah, I think I saw some project. I think they call it like maybe AGI 2027, something like that.
Mm-hmm.
And they have this estimation of like when AGI will arrive. And then recently, I think like 2 or 3 days ago, they announced that like things are too slow than we expected. So now like we postpone it to 2028, like the AGI,
Yeah. Are you
because like
familiar? Are you
it
familiar
was,
with Eliezer Yudkowsky? You know what that is?
Oh, I
yeah, of
do. Dear
course.
God.
Yeah,
Nice.
he's something. I think he had an article in the New York Times recently where he was being interviewed by a reporter, and he says to them, just to let you know, like you're going to be dead in 5 years because like AI is going to kill you. I think
He
that's how
was
he.
saying that 10 years ago, though. Come
I know.
on.
Although the best part of this article, I have to say, I think there was like a side comment where the editor was like, he becomes more or less optimistic depending on how happy he is in his personal life about the
Yeah,
future
exactly. He's famous
AI
for
killing
this.
us
Like,
all.
people need to go on Less Wrong to understand that guy. And yeah,
Yeah,
anyway.
I think we talked about it also like a few episodes ago. I think like the main problem is that we don't know. We really don't know. And I think like even people that are working in this field and, making and develop like the frontier models don't know what will be in the next year or 2 or 3 years. So to say that something will be in 3 years is basically to say that, yeah, I see some progress in the last, I don't know, year,
Right.
not there in the next months, but maybe we'll be there in the next year, 2 or 3 years from now.
Yeah, progress is funny. I think people don't realize progress until it reaches a certain point. Like, to give an example, whenever I tell people that I'm doing a PhD in AI, I almost always get the same reaction. They always say to me, really? That must be new. I've gotten this more than 20 times because people think that AI started with ChatGPT, which is kind of funny because you have to realize that that didn't come out of a vacuum. But I think in general, same thing with robotics, that we're not going to see progress until we do. And then when we see the progress, it's going to be kind of obvious in hindsight that's been building towards it.
Yeah. Or we'll not see a progress at all.
Right. And then it won't be obvious in hindsight.
Yes.
Yes.
It's also a
definitely.
possibility, right?
Yeah, it's for sure a possibility.
Yeah. Okay. Maybe let's talk about a very interesting project that you involved in. How to make the reproducibility crisis better.
Yes.
So let's start with what does it mean even, this crisis?
Yes. So the reproducibility crisis is basically the idea, and this is not unique to machine learning. In fact, it's primarily, it first was really spoken about a lot in psychology, but it's the idea that a lot of peer-reviewed research cannot be replicated. I'll give you a very funny anecdote. There was a famous study in one of the journal, and it basically went like this. They basically showed that they would, give me 1 second, I'm trying to remember the exact detail. It was something along the lines of they would basically have like a box, and behind the box, there would be a photograph. And the photograph would either be like something sexually explicit or something not explicit. And this peer review study basically claimed that like people's behavior would change based on what was in the box that they couldn't see. This was like the peer reviewed study. And this got published and it got a lot of media attention, as you can imagine, because it's basically saying humans are prophetic. Then came along an attempt to reproduce the study, right? Because we got to see, how does that work, right? How can we do it? And there was a big attempt to reproduce it, and they showed that this is not reproducible, right? And they submitted this to the same journal, and the journal said, sorry, this is not novel enough. We're not interested in publishing it. Can you imagine? So this is an actual story. I forgot the name of the paper. I can send it to you afterwards if you want to include it. But this really happened. So maybe in machine learning, it's not quite that bad. But we do have a crisis where a lot of papers are just not reproducible. And the reason why this is probably is there's a lot of pressure to publish, and people want to get out results, and the results are then therefore more incremental. And there's also a lot of evidence that in peer review, reviewers are much more generous towards incremental progress than totally novel ideas. And it's somewhat understandable why. I think it's because reviewers are lazy, and it's very easy to evaluate. I'm a reviewer. I'm lazy. I'm speaking from personal knowledge. It's very easy to evaluate an incremental progress. You know what the state of the art is. You know this is a little bit better. It's super easy. But to look at something new and different, and it's not beating the state of the art, and to say this is a good direction takes a lot more knowledge.
But do you think? Wait, I will try to push back a bit, because like even if you are an expert in the field and you're you don't care to work really hard, and you read the paper 10 times, all the references and all the
Yeah.
things, like even in this case, right? Like it's not clear to me that even if I say, okay, this is a very novel idea, but it doesn't get good enough results, right? If it's a novel idea and get really good results, we don't have a problem, because we all agree that it should accept, and I think most of the reviewers will agree about it.
For sure.
But what if it's a novel idea, but the results are not good enough? Do you think it should accept to a top tier conference?
Probably not. But I want to kind of hammer in on is, what does it mean to get good results? I think that's really the question. I think it's a huge mistake when getting good results is focusing on a single top metric. I think that's really the issue. So, if a method can't get good results on any metric, I agree. But just to talk about like machine learning models, like we shouldn't just be looking at accuracy, for example. Like we should be looking at a much wider variety of metrics. The way that I like to think about this is something called the Pareto front, which basically is an idea for multi-objective optimization. I don't know if you're familiar, but basically the idea is, imagine you're trying to optimize, let's just keep it simple, 2 objectives, right? So you want to find solutions that optimize A and optimize B. So how do you do it? Right? So like the trivial approach is you have a weighted combination of A and B, right? Some function, whatever it is, it could be linear combination, what have you. And then the better you can do at this is the best, right? But that's really kind of giving some external structure into the trade-off. So the way a Pareto front does it is it says basically we can kind of take every solution we know about and we can graph where it lies on A and B. And then there are going to be some solutions that they're called on the Pareto front that basically, there's no solution that does this good at A and also does that good at B. And so that basically tells you, which solutions are on the front and which are meaningless. And so if there's something where, it's maybe not amazing at metric A, but it's beating everything at metric B, that's interesting. And so I think we need to think about that a bit more.
Yeah, but it's much harder to do it when you have a lot of dimensions, right? A lot of different dimensions and a lot of different
Yes.
tasks that you want to solve. And sometimes it's not even clear what the tasks are, right?
Yes, absolutely. And it's also much harder to tell the story, right? A story of, this is great, it does better and everything is a very straightforward story.
Yeah. No, I agree. I think like if you ask me, this is the main problem, like to tell a story. I think like most of the papers and most of the papers that people consider as good papers tell you a good story. And this story, most of the time, it's not even true, right? You have no, like you right. Most of the time when you read a paper, you have like they give you intuition, very good intuition, and then you see like how like different components of this algorithm method works, and then you see that it works better than other models. But most of the time, this is not how the research process it actually works. Most of the time, you have very, very rough intuition that it's not even correct, right? Like you change it over time and you adjust it and you try to.
And the story only emerges
scale.
as you're writing the paper.
Exactly. And I think this is the main problem. Like we need to understand how to get papers even without a good story.
I'll also add that what you just described about like, the story changing as you go along. I have met people, I agree with you on this, but I've met people that are very critical of this. And they say that that's not real science. And if your hypothesis is changing as your results are coming in, then you're not really a scientist.
Okay, that's BS. I'm sorry. I will get into this because the
I agree with you. I
scientific
think it's BS
method,
also.
the scientific method as articulated in school is like actually wrong. And my favorite like philosopher of science who had the God, what's his name? Well, Peter Furiband, who wrote God dang it, what's the name of this? Hold on, I'm sorry, I'm just forgetting some names. Against Method is the relevant book. Yeah, by Paul Furiband, and he had the guy for the paradox of tolerance. This is to Karl Popper was his advisor. So yeah, he spent multiple books being like, no, the scientific method is not how science happens, and analyzing this and basically saying that any method that creates a reproducible effect is science. Basically, science for him is reproducibility.
I tend to agree. I think the results speak for themselves, right? If
Yeah.
whatever we're doing is producing science that's working, then it's science.
Yeah.
You say that like you want to make reproducible to increase the reproducibility of projects of different kind of papers or whatever. The question is, at least an important question is why? Like I can imagine a world that a valid claim will be that I don't care about reproducibility. Like we have enough people in machine learning today that will try the things and like the good things will just show up. More people will use them. And as more and more people will use them, they will validate their results in different settings, right? You don't need to reproduce the exact setting of this specific paper.
Yeah, it's a really interesting perspective that I've thought about too. I think it's very contrarian to a lot of academics. I don't necessarily disagree. I think machine learning has a lot of privilege in the fact that we have so many people working on it. I think most of science can absolutely not take that approach. I think that will kill almost any scientific field. Maybe we can get away with that. I do agree that there is some possibility. I mean, we have. Let me say it better. We have been getting away with that.
Exactly. In some sense, this is what's happening today, right?
Yes.
Good methods are replicate because they are working in practice. People are taking and they are trying to use them in different settings.
But it has problems where a lot of good methods that don't get their time where somebody tries it, or methods where some people try them, but they don't proliferate for other reasons. For example, a ton of LLM sampling work is just sitting there not used. Tons. In fact, DeepSeek V3 came as such a surprise to the market because nobody read DeepSeek V2 or V1. Nobody, right?
Yeah. And I'm going to add I'm going to talk about first, I think, one solution to solve this problem. I think that will also answer your question about why we want to solve it. So the solution that it's been argued by a bunch of people, I think David Donahoe has a piece where he argues this as well, is basically we need to get rid of people evaluating their own algorithms and self-reporting the results. if we can move to a place where people, they have their algorithm, but then there's some central submission platform. People submit their algorithm, and then it gets graded on a true test set. So they can't just p-hack, they can't submit 1,000 times, right? So he argues that that's kind of the solution. And and then to answer your question, the reason why I agree with him, I actually wrote a piece with him about this that hopefully will be put in an archive at some point when I get around to it. But the reason why that he thinks and I think that this is a good idea is, if you look at all the examples of fields or subfields of machine learning that did this, they saw much more rapid progress than everybody else. There's a lot of examples. So the simplest example is ImageNet, right? The ImageNet challenge was the catalyst of machine learning, right? And the way they did this is they had a big challenge. Everybody was submitting. You couldn't really cheat. You couldn't really cheat so well. That's kind of one example. Another example people talk about is AlphaFold, right? Where if you look at basically once protein folding became a well-defined challenge, there was a centralized thing. Everybody's competing. You can't cheat. You can't, hack your way through it. This is the metric. This is your score. This is what you did. Once that happened, you can look at like the graph of like how good the solutions were. It just shoots up, just like ImageNet, right? Once cheating is eliminated and there's strong signal, less noise, progress is so rapid. There are more examples too. I'm trying to remember more of them offhand. There's a lot of examples of this.
Kaggle is a great example.
Kaggle is a great example. I love Kaggle. I'm currently working with them on 2 different Kaggle contests.
Yeah, but Kaggle scares me because I don't think I could ever get a gold medal or anything. And so I'm kind of glad that Kaggle didn't catch on, because it's too good at separating the meat from the fat.
Exactly.
No, I won't be allowed in the industry if you guys force me to get
Alan, I have the solution. Be a contest organizer. That's the solution.
No, but but this is it's quite a valid point, right? Because like at the end, we talked about it before, right? That like you have a lot of solutions, and it may be that good solution, at least at the beginning, will not get a good result, like good enough result, right? And it may be that like people will stop working in this direction because the only valid metric that you have is something that it's very clear, right? Like you're better or worse than other methods. So if I can't beat like other methods, then I would just stop to work on this direction.
I agree with you, which is why. So in the actual proposal that I was working on for this, it was a bit more complicated than kind of what I said. And basically, we're advocating for a mixture of both a centralized kind of system, but one that incorporates directly many metrics. So maybe unlike ImageNet, the vision here is there's one challenge, but there's going to be a leaderboard with 8 metrics, right? Which Kaggle does not do, by the way, because Kaggle's focused much more on like prizes and money. And obviously, you need a winner. But I do think for the science perspective, if we could have, pick a field, we have one centralized system where people can't cheat, but we can still report lots of metrics. It doesn't need to be one metric.
Yes, I agree in principle, but it still can be that like people will work or like want to work on something that it doesn't get the best results even on different metrics, but it's a good idea. And if again, it's something like, I don't know, like if there is something that you can cheat, that you can keep working on it through that, and you can keep continuing improving it, it's something good, right? Like it's maybe not optimal, or like maybe like we don't need to emphasize it, but I think it's something that we still should do.
I agree. I don't think we want to eliminate that. I agree with you. I think this actually gets into another thing that I wanted to talk about, which is how can industry keep up with, how can academia keep up with industry? I think the main answer is what you just said. In industry, in academia, we're never going to be beating Gemini on some benchmark. We're going to just fiddle around and find something interesting that our model does and publish about it, which is exactly what you just said. So I do think there's truth in that. But the question becomes, if your goal is solving a particular problem, then you need a centralized system where people can't cheat, right? So maybe as an individual researcher for some of my projects, I'm not going to want to be doing this. But if my goal is to solve protein folding, if my goal is to solve insert problem here, you need a system where people can't cheat, they can't p-hack, and the results are clear. And once you have that, you'll see rapid progress. That's kind of the argument.
So do you think like we should have like, how do you imagine this system kind of like I know Kaggle with different metrics? So what we're going to do regarding compute? Do you think you want to normalize by compute or take it into account?
Great question.
Thank you.
I love Kaggle because it has all the momentum, right? Everyone knows Kaggle. So I'm always a little bit skeptical of people that are trying to reinvent Kaggle because it does a great job of this. But at the same time, I would love if Kaggle would just incorporate more metrics. In fact, I've actually told some of the leadership at Kaggle about this. I actually had a very funny serendipitous meeting when I was at NeurIPS last year. I went to the Kaggle booth and I started telling them some of my ideas, and then it turned out I was talking to the CEO. I didn't even know. His name is Pete Scully, although he actually stepped down like a week later, so I don't know how much it mattered. I wish Kaggle would just take it all its momentum and make some slight tweaks to basically support multi-metric, reporting.
Well, and I come from a, most of my scientific contributions, in fact, all of them are not, well, maybe MinP is the one exception, but they don't claim to be state of the art at anything per se, right? In the sense of, I mean, I guess anti-slop is like we're really good at removing the slop too, but we're not targeting like some kind of benchmark that's easily written about. Often we have to invent our own benchmarks, and we're showing off new like hacks or methods or presenting data sets. And I've also seen critique recently on Twitter the idea that every paper has become a data set or benchmark paper, and people kind of not liking that, when I swear I heard critique 3 to 5 years ago about how nobody had any evaluations or data sets or benchmarks at all. And so I don't know what we're supposed
I
to
am
do.
totally not sympathetic to their critique. I think more data sets, more benchmarks are great. I don't understand the critique at all.
Yeah.
It's not
Somebody
like
on
people
Twitter.
are only working on that and stop working on other things, right?
Yeah, I agree. I think like we should have more benchmarks, but I think I don't know, in some sense, like when you have more and more benchmarks, you kind of like overfeed to these benchmarks. You need to keep, the right balance between benchmarks and real user experience and things like that.
Yeah.
Yeah, but I think on that note, what you said earlier will work, where the good benchmarks will rise to the top. I think in that area, I'm kind of okay saying the things that are useful will be used, and the things that are really not measuring anything important are going to fall by the wayside.
We have a huge gradient descent of all the researchers in the world.
Yeah,
right?
I like to call it graduate student descent. You ever hear that one?
Yeah.
Yeah, stochastic graduate student descent. You got a lot of graduate students, a
Yeah.
little bit.
And then they go to OpenAI and implement it, everything.
If you shake them enough.
Yeah, sure.
Again, don't try this at home. For whoever's listening.
If you have a battle with graduate students, don't do it.
Yes.
Okay. Do you want to talk about something else?
Let's see. I think we covered most of the topics.
Have we talked about smart buildings at all? I don't think we have.
Not really. You want to talk about that a bit? I'm happy to.
Oh, yeah, because that's kind of what I considered you an expert in.
Sure.
Really was like built. So Judah, the smart buildings work that you've been involved with. I think the first thing maybe just to ask is, what is a smart building? And by making buildings smart, whatever that means, what kind of improvements or efficiencies do we get?
Yeah, great question. So it's, first of all, smart building can mean a lot of things, but basically what we're saying is, can we use machine learning AI to make operation more efficient and to make humans, more comfortable or enjoy the experience more of being in the building? I like to give the pitch, like, buildings are pretty popular. In fact, you're both in the building right now.
Yep.
So they really make their way around. And we spend most of our lives in buildings, right? And they haven't really changed much in the last, 30, 40 years. And so at the very basic level, can we improve upon that? The simplest way to pitch it is, heating and cooling is usually the largest cost in the building. And the question is, can we do heating and cooling for A, less money, and B, less carbon emissions? And the reason why this is great is people on the left and the right both like it. So it doesn't matter, you're worried about climate change, you're worried about saving money, whatever it is, whatever your beliefs, we can get behind less of it, right? And so it's, kind of a very well-stated objective. And there's a lot of low-hanging fruit because buildings today don't do anything. To give some simple examples, there's basically no buildings that know the weather forecast. So simple, right? The next 2, 3, 4 hours of weather. And there is so much low-hanging fruit you could do, right? You know that in an hour, the temperature is going to drop. Okay, that's great. Maybe I don't need to cool, right? Maybe I don't need to cool the building anymore. So many things like that. Another thing that's not taken into account also is price fluctuation. So the price of electricity and natural gas varies significantly throughout the day. There's peak hours, off-peak hours, right? Buildings don't take this into account. You'd much rather heat your house at the off-peak hour and then let it drift a bit during the on-peak hour.
Well, okay. One quick question then. I know that Apple at least is doing shenanigans with charging devices. So maybe the building doesn't, but individual devices in the building are starting to, right?
When you say charging, what devices are you referring to?
So like Apple devices will not charge during peak hours when like electricity is most expensive, right? Like they have a thing in there about the like waiting to charge until at night or something when nobody's using it.
I'm not familiar with that. Definitely could be. But yeah, that's definitely not being done at scale. And I'm not talking about charging. I'm talking about like things like, should the air conditioning be running in your house, right? Like those types of questions. So there's a lot of low-hanging fruit. There's also more complicated things that could also lead to huge efficiency gains. And this is kind of going into the weeds a bit more about how these systems work. But basically, you have a lot of different devices that are working together to do what you want. Just, let's say you say, I want this room to be 70 degrees Fahrenheit, right? What that really means is you want it to be between 68 and 72, right? There's an allowable range. So when you say that, there are hundreds of devices in a large building that are responsible to make that happen. And there are many ways you could set those devices up and like configure them differently that would give you the same result, but in a very different way. Just to give a simple example, let's say you want to heat a building, right? Usually you have a boiler, right? So you could make the water temperature very hot and circulate the water slowly. You could make the water less hot, circulate it very rapidly. Those are both different ways of using energy. Which one is more efficient? I don't know. It might matter based on the building, based on the time of day, based on all sorts of factors. There's so many different levels of complexity, and basically no one's done this. So I'm working on this at Google now for about 4 years. I think I'm actually, by the way, here's a fun fact. I'm pretty sure I'm the longest tenured student researcher currently at Google.
Did you check it?
Is that good or bad?
Well, it means they keep renewing me. So I don't know. That's up to you to interpret. The reason why I think that is because I'm now there for 4 years. And it turns out that there's some internal rule that you can only be there for 3 years max. And they're like, how did this happen? I think so. I don't know. I think I'm the longest one there. So I've been working on smart buildings there for about 4 years. And I've also been leading a lot of efforts to kind of bring this problem to the machine learning community. So I was a lead organizer of a workshop at ICML. I'm organizing a workshop at NeurIPS basically on this topic. And I've kind of been working on like galvanizing people. There's a whole world of building researchers that are working on this, and they don't know about AI people, and AI people certainly don't know about them. So there's like a lot of collaborations that should be happening that aren't. Yeah. I was literally on a podcast this week, on a buildings podcast. I don't think they know about you, and I don't think you know about them. So there you go.
Yeah. You're the connection between us.
Yeah, I guess so.
So what do you think? Like, do you think like we will see, very like some adaptation from classical or like more recent advanced algorithms that people are using in AI in this field for smart buildings?
Yes, although I think the problems are maybe not what you'd think. So one thing I found anecdotally, I've gone to a lot of different conferences now about this, both machine learning and not. In fact, just a side funny note, I went to a conference on air conditioners, and it was in Phoenix, Arizona in the summer, which I think is the best place to have a conference about air conditioners. So, you really appreciate, their importance when you're in Phoenix. But anyway, I find that people in the machine learning space are somewhat surprised that this is not already solved. Partially because there were a lot of papers from DeepMind and others that said they solved it. Maybe you've seen these papers, maybe not. And people in the building space are very confused that AI people think it's been solved. They're like, no one's made any progress in this. What are you talking about? I think a lot of the issue really boils down to something that we mentioned earlier, which is the difficulty of configuration, especially of a simulator. So if you want to optimize a building, you need a really good simulator, right? Energy Plus is the DOE simulator. At Google, we built our own simulator, and there's a bunch of different options out there. We built our simulator because we think that there are a lot of issues with the existing ones, but basically the issue with these simulators is they take so long to configure to one building. And so basically all the research out there, it probably works on like your building in the winter. But if the season changes or you move to a different building or you freaking close a door sometimes, like really basic stuff, it all gets out of whack. It's really similar to robotics in that sense. And so I think that the simplest step that AI can help is like a lot of generative AI is very good at going from like images or floor plans to like, 3D schematics. We can have nice ways of actually automating the process of, going from a building to a simulation of that building in an accurate way that doesn't involve thousands of human hours. I think that would basically solve the problem.
But do you think why it's so hard to simulate it? Do you think because we have a lot of factors, like a lot of different factors
It's
that
so late because
affect and
it's so hard to simulate primarily because every single building is different in a lot of ways. First of all, the physical structure. Every building has different structure. The number of floors. Is it facing north, south, east, or west? That matters too because, solar radiation is big. Are there windows? All sorts of properties. Every building's different. And that's just like the structure. There's also the HVAC system that's doing the heating and cooling, and that's different. Is the boiler this model or that model? Does it do water heating? Does it do air heating? Does it do it this way or that way? There's like 1,000 ways. Even within Google has like 400 buildings or so that we look at. They're so different. And this is like one company's portfolio of buildings. And they're all being run by the same management system. They're so different. If you leave outside of that, there's also 1,000 different building ontologies. When I say an ontology, it's like, you have a physical system. How are you going to describe it in software, right? There are
but
so many ways of doing it. Nobody can agree on how to do it. So,
but
yeah.
do you think like the problem is that like we don't have enough data, that like these buildings are not collecting data? Let's assume like in ideal world, right?
Yeah.
We will have all the data, all the buildings will collect data all the time, and let's assume that like we agree on some format, right? So do you think we can integrate this data and make a robust enough system, or like you think that it's very specific, like the data basically you can't average out the noise, right? Like each building you need to collect its own data and only to use it for this specific building?
That's really, really is an essential question that I've been working on and thinking a lot about. I call it like foundation models for buildings or transfer learning for buildings. I think it's a really great question. The biggest challenge actually is how do you collect that data? Because usually buildings, when you're collecting data, are operating on a baseline policy, right? So the data that you collect is going to be from their baseline operation. And that's not so useful. If you really want to collect good data, you have to be like varying all sorts of things, try this temperature, try that temperature, turn this off, turn this on to get a real idea of the distribution. But in a real building, no one's going to let you do that for good reason, right? It will destroy their building. Let's just see, how long does it take for the pipes to freeze? If I turn off the boiler, will the pipes freeze in a day? Like, we want to know that maybe, but like no one's going to let you experiment like that, right? So the real problem is you can't collect the right distribution. Now, maybe there's a whole field of reinforcement learning called offline reinforcement learning that tries to solve this question of like, what if you only have data from a baseline policy? And the answer, maybe they don't, well, they might say the answer is you could, but I would say the answer is really you can't. Maybe a teeny bit, but it's very, very hard. And we've only seen results on toy problems so far in this field. So that's really the issue. So we need simulations because in the real world, no one's going to let you do the proper exploration needed to answer these questions.
I want to say that it's quite surprising that there are no more startups or companies in this field, because it's like it's real world problem, right? Like it's a very concrete problem that if
Yeah.
you solve it, you can, earn a lot of money, right? A lot of companies
Yep.
will pay to solve this problem. And I will imagine that you can collect more data, you can collect much better data, much more accurate data, and to just put more money in order to solve this problem. It's
I
something
agree.
that,
I think it's a great startup idea.
yeah,
I
yeah,
agree. I mean, I'm not going to say there are no startups in the field. I know a few. It's not where it should be. Yeah.
yeah. We are taking 5% from the startup. Yeah.
Noted. Yeah. Another challenge though that a startup has to contend with also, and anybody has to contend with, is retrofitting. So if you want to do a startup, right, you can't you have to actually be able to work with lots of buildings. You can't just say I'm going to work on a modern Google office building that has sensors everywhere, everything's new, everything works, right? In order for this to work, you have to be able to say, no, I'm going to come into a new building. Its HVAC system is from 1974, and we're going to still do this, right? And that's much harder. I still think it's possible, by the way, but it's much harder.
Yeah, and also like it's not clear how you actually validated it work. Like what is your critiques, right?
Well, that is a good point. The main reason why it's hard to validate that it works is because you can never really do an apples to apples comparison, because when you try the baseline and then your model, it's different weather, it's a different day. It's very hard. I have some colleagues, Professor Bing Dong at Syracuse University. He built 2 identical rooms that are perfectly the same, and they have the same weather, they're in the same location, because that was the only way they could actually do A/B testing on this stuff
And does it work?
for their buildings in the right seasons.
Okay. Yeah, with the right sensors.
The right sensors, and if you squint just a little bit, it works. It works for their building, but it haven't gotten to a point where it works everywhere.
Oh, are the sensors more important, like to have lots of them for these smart buildings? Because it always seemed to be that the sensors were an integral component of all this, like smart driving and also smart buildings, right?
Yeah. Sensors are a critical component. The main question you have to ask, there's kind of two different types of sensors. There are sensors that are telling you the state of the building, and then there are sensors that are telling you the state of the HVAC system. The first group is pretty easy, right? The state of the building boils down to things like temperature, air quality, whatever. Those are simple sensors. You can place them anywhere, and they don't need to do that much. But the sensors that are actually measuring the HVAC system, which is the control system, that's much harder, right? How do you get a sensor that accurately tells you the temperature of the boiler, right? You got to go in there and hook something up. How do you get a sensor that measures how fast air is moving in the ducts, right? And then in addition to that, you also actually need actuators, right? You need to be able to change the temperature, right? That's a whole nother level of complexity. So yeah, it's very important, but it's more challenging than it sounds.
And do you think it's something that is solvable? I think like in the
Absolutely.
near
This is a
future we
solvable
will see.
problem. There's a major economic incentive. It's certainly solvable. It will get solved. 100%. Yeah. Maybe by me, maybe by somebody else, but it will get solved. I'm very confident.
Okay, let's hope that it will be by you.
Yes, I like that.
Okay, anything else? Alan, do you want to say to ask something more?
So, do certain building designs, or even like, is there any part of this that gets to like interior design, for example? I ask
Absolutely.
because there's like concepts, in Asian households of like feng shui and other, I think, analogies. I think
Yeah.
feng shui is a Chinese variant, and I'm curious, is there like some connection here even to stuff like that in some?
Huge, enormous connection. So I was invited as a guest speaker at some conference at the Harvard School of Design because of this connection. So there's a big connection. That was like it was mostly architects there. Actually, it's really interesting. Yeah, they're very interested in this. They're interested in like, how do we build the buildings of the future? So there's a group at Harvard led by Professor Ali Malkawi, who I've been working with a bit too, and they built something called House Zero, which basically, it's the coolest thing. They gave me a tour when I was there. It's really, really phenomenal. It's like a carbon neutral house. They basically built it, and it also has complete natural air ventilation. I've never seen anything like it. It's like the most
What a
futuristic
thing.
house. It's also, by the way, they have like weird regulations in Cambridge. So like from the outside, it looks like a really old. It has to like fit the neighborhood, right? So it looks like an old, dilapidated, random house in Cambridge. But then when you go inside, it's like the most futuristic thing. Everything is controllable. The house is giving energy back to the grid. Yeah, it's really phenomenal. So like the design people are much more interested in it. And if you're a businessman, you want to know about retrofitting, like we just discussed. But if you're looking towards the future, you want to say, can I build a building that doesn't need any of this? And yeah, the answer is yes. So it's really cool at Harvard. And also, I mentioned the group at Syracuse. I got a tour of their building also. They have all sorts of like really out there stuff. They're doing a lot of material science behind this too. They have like they showed me like a species of like fungus that they're growing, like a mushroom that apparently is good for building insulation and also like removes like carbon dioxide from the air. Something wild. Like there are all sorts of really out there ideas that you can get into in the design space. Absolutely.
The best solution is to live in the forest, with all
Live in the
the
forest.
mushrooms.
Exactly. Yes. Be a monk. Right. Who needs any of that material desire? Buildings are
Yeah.
Well, okay. Well, one other.
Meta's AI data center and just live in a tent.
Well. So, what do you do? Does anything from the smart buildings movement will this have any impact or influence on mobile, like modular homes, like RVs, that kind of thing, where it's a vehicle and a building?
Interesting. I never, it's a great question. I never really thought about it. But yeah, I mean, I would have to assume there was going to be definitely a connection. I think this will really influence all buildings. Once this works at scale, why would you want to pay 10% more in your electricity bill? Whether you're living in a mobile home or on a house, on a boat in a house, or in the forest. I don't know. Like, why would you want to pay more money, right?
Yeah.
I think it's going to be, very influential. Yeah, although now I'm kind of curious if people have thought about this for mobile homes. I don't know. I think it's actually interesting because people in mobile homes in general tend to be more interested in like experimentation, right? People in buildings are very risk averse. They're like, no, it works. I don't, I'm making money or whatever. Like, I don't want to try this out. But maybe that's more of an untapped market.
Yeah.
Okay. Yeah. So to to summarize, like we'll have buildings with robots inside them that will manage everything, right? And everything will, and we just need to sit down and to.
We'll be living in a utopia. Yeah, they'll even do the podcast for us.
Yeah, exactly. I don't know. Like, I hope the robot that will actually make the podcast is already in progress, right?
Maybe. I don't know.
Someone.
What do you say?
That someone is developing it right now when we're talking.
Probably, although that does seem a bit dystopian to me. I don't know if I want a robot making a podcast. I have a friend of mine who was working at a startup that was basically making AI generated podcasts, and I was not impressed. Let's just say that.
So speaking of that, our anti-slop paper is one of the most popular slop videos on a slop podcast. I have to show you. It has like 500 or 600 views and some comments of them having fake people talking about our paper, and it's very fascinating. I hope somebody writes about this.
There's a good irony in that.
Yeah.
Yeah, I don't know. I think in general, we're going to see pushback on this. I am a believer that with the current wave of generative AI, within a pretty short time, we're going to start seeing people pushing back hard and not wanting to consume AI content.
Oh, yeah. Well, and beyond just like anti-AI folks, I think that reliable AI text detectors are going to proliferate soon. And a lot of people who used it in places where they probably shouldn't have are going to get in a lot of trouble retroactively.
I don't know.
In
I
the
think
future,
it's, I think it's very hard to solve that problem because it's like chasing its own tail. The AI is trying so hard to imitate humans, right? So it's very hard to get them to be reliable.
Well,
yeah.
Sorry, keep going.
Anecdotally, maybe it's easier than we think. I think yesterday or 2 days ago, I was writing something. I asked ChatGPT what it thought, and I couldn't tell what edits it made. So I said to it, "What did you change?" It said, "I just added M dashes." So that's what I said.
Really? Oh my god!
I actually screenshotted it. I was like, "Wow, like it's really, really doing what it says."
Gosh.
The AGI is coming. The AGI is coming.
The huge M dash. Listen,
No,
at least
okay.
now we'll have 5 fingers, so we made some progress.
I think we should finish with this optimistic thing, right? Okay, Judah, thank you so much. It was really, really interesting, and hope you come back again.
Thank you so much for having me. It was a pleasure.
Always
Thank
a
you,
pleasure,
everyone.
Judah.
Bye, everyone.